Hey y'all, welcome to 10.5. This is the parabola piece of this video. You've dealt with parabolas before and you're used to this U-shaped curve and you're used to an equation y equals x squared. All that still applies. There's more complex things that can go on with parabolas. And parabolas have a vertex, which we've dealt with many times before. They also have a point called a focus, and they have this line called a directrix. So in the definition of a parabola, seen up here, the set of all points to which the distances from a fixed point focus and a line directrix is constant. So what that means is that this point on the parabola is the same distance from this focus as it is perpendicular to this line. Now, this parabola is not perfect, so forgive us. Okay, same thing at any point on the parabola, the distance to the focus and the distance perpendicular to the line are going to be the same. It also works here in the middle from the vertex to the focus and the vertex to that directrix. Those are congruent pieces as well. And that length is P. And that P factors into our equation here in just a minute. So in a parabola, a vertical parabola has x squared. Like y equals x squared is that vertical parabola that you're used to. So vertex form is here. That's a form you're used to very much. There's also a conic form. And the conic form is here. X minus h in parentheses squared is equal to 4p times y minus k. There's that value of p we talked about. Now, that vertex is h comma k. H is always with the x, k is always with the y. The focus is p units away from the vertex. And the focus is inside the parabola. So the focus on a vertical is 3 units up from the vertex. The parabola were flipped over, it'd be 3 units below. So that focus has the same x coordinate, h. The y coordinate is the center plus p. Now, beware, p can be negative, which would turn that into a k minus p. The directrix is a line. It's a horizontal line. Horizontal line is y equals. It's p units below the center. Here's the vertex, here's the directrix. It's p units below the center. So that center y coordinate is k minus p units. K minus p. Then the axis of symmetry, same as what it's always been. Axis of symmetry is the vertical line that goes through the vertex. It's a vertical line, so it's x equals. It has to go through the vertex, so it shares the same x coordinate as the vertex. X equals h. Now, you see on the next page, we see a horizontal parabola going sideways. Okay, this is an x equals y squared parabola. That one opens sideways, left and right. It's like it fell over on its side. So, same idea applies. We have a vertex. The focus and the directrix are both p units away from the focus. So, vertex form and conic form are here. Conic form is what we'll use most often. Y minus k all squared equals 4p times x minus h. It's the y that's squared. X equals y squared. That's what makes this horizontal. Vertex is always hk. H is with the x, k is with the y. So h comma, K. The focus, if we look, is P units away from the vertex. In this case, it's P units to the right of the vertex. So that X coordinate changes, H plus P, that Y coordinate K stays the same. The directrix is a vertical line. It's going to be X equals. That X is P units to the left of the vertex. So that vertex's X is H. H minus P is that directrix. Then our axis of symmetry on this type is horizontal line. That's Y equals. It has to go through the vertex. So its Y coordinate, K, has to be the axis of symmetry, Y equals K. And there is how we do a parabola. So if we take a look at example 3, let's put this into play. Using this conic form, y is squared. So this is horizontal. Okay, this is horizontal. So the negative in front of that 4p value means it's going to open backwards. In this case, it's going to open left. Okay, so opening left. Okay, it's a left-right because the y is squared. It's left because of that negative coefficient. Vertex is HK. H is with the X. It's going to be 1. K is with the Y. It's going to be negative 2. So 1, negative 2 is our vertex. Okay. That axis of symmetry, okay, if we look here, it's Y equals K. So in this case, Y equals negative 2 would be that axis of symmetry. Horizontal line at Y equals 2 through the vertex will be that axis of symmetry. Now, the value of P is that coefficient of the non-squared term. Okay, negative 8 is 4P. Look at the conic form of the equation. So P is negative 2. What that means is that the focus and directrix are negative 2 units away from the vertex. The focus and the directrix are negative 2 units away. Now, that negative 2 feels weird, but it's okay. It just means it opens left. So that focus is 2 units to the left. That directrix is 2 units to the right, and that directrix is a vertical line. DIRX is a good way to abbreviate directrix. Okay, so that focus was 2 units left. Okay, we can use this formula, H plus P, comma K. H is 1, P is minus 2, comma, K is negative 2. That focus is negative 1, negative 2. And if we look at where that got plotted, negative 1, negative 2 is where that landed. That directrix is X equals H minus P. X equals H is the X of the vertex 1 minus P is minus negative 2. That's 1 plus 2. So that is X equals 3. And if we look at where that vertical line landed, that vertical line is at X equals 3. Now, there's one other piece that we can put on here, and that is focal chord length. And there probably should have been a spot to put this in all of those definitions. And there is. We're going to go back page just real quick talking about this. There we go. For all parabolas with a vertex HK, P is two things. It's the distance vertex to focus, and it's the distance vertex to directrix. It's that value P that we see right here on that graph. Then the focal chord of a parabola, the focal chord, it is the distance across the parabola through the vertex. I meant through the focus. The length of that focal chord is 4p. 4p from the equations. So, on our example, the length of that focal chord is 4p. It's 8, and it's a length, so we consider it positive. It's actually the absolute value of 4p. So 8 is the length of that focal chord. And what that means is from through the focus, the distance across the parabola is 4p. So 8, half of 8 is 4, up 4, down 4. Our parabola goes through those points. So our parabola would curve here through the ends of that focal chord, through the vertex, and out. And there is a horizontal parabola. Now, let's check out 4. The x is squared, so this is a y equals x squared parabola. It's going to open up and down. This 8 is positive, so it's going to open up. Parabola will open upwards. So the vertex is HK. The x-coordinate is with the x. It's going to be 3. The y-coordinate is with the y. It's going to be the 6. So 3, 6 is our vertex. 3, 6 is the vertex. The axis of symmetry has to go through the vertex in the direction the parabola goes. It's going to be a vertical line. So that's x equals. It has to go through the vertex, so it has to have the x of the vertex. X equals 3 being your axis of symmetry. P, 4P is 8. So P is positive 2, meaning the focus and the directrix are 2 units away from the vertex. So from the vertex, up 2 is the focus, down 2 is the directrix, and that directrix is a line. So the focus, okay, if we use the formula on the previous page, told us the focus is H, K plus P. H is 3, K is 6, plus P of 2 is 8. And if we look at where that landed, 2 units up, P, 2 units up, is 3, 8. That directrix, the formula says it's y equals K minus P. K is the y, which is 6, minus P, which is 2. 6 minus 2 is 4. So that directrix is y equals 4 And if you'll look where we graphed that directrix, it is that horizontal line at 4. The focal chord length is the absolute value of 4p. In this case, that is 8. Okay, half of that is 4. So through the focus, 4 units left and 4 units right are points on that parabola. And here is the parabola through the vertex, through the ends of the focal chord, and there is your parabola. So there's graphing parabolas in conic